Hello, and welcome to this edition of the Awards Intelligence 6-Minute Webinar. I'm Bob Gritzinger, Senior Analyst, and today I'd like to share some insights from our recently published report on automotive electric traction motors. This in-depth report studies how the industry has been working to design, engineer, and produce ever more efficient e-machines to meet the growing demands of the global automotive market. The report looks at the market for motors, the cutting edge of e-machine technology, the evolving relationship between automakers and suppliers, and provides a detailed examination of suppliers who are working on electric powertrains. For now, the primary motor for most electric vehicles is the permanent magnet motor, so called because it relies on permanent magnets and electrically magnetized windings to generate mechanical output. A second option, employed by Tesla in some of its high-performance models, is the induction motor that requires extra electrical energy to induce the level of magnetism necessary to drive the motor. So why the different choices? Induction motors tend to be less efficient at lower operating speeds when most driving cycles occur, but are good for high-performance applications. Permanent magnet machines are highly efficient at low and mid speeds, but their efficiency drops off at higher RPM. And those are just a few of the mainstream motor technologies we're seeing. One need not dig much deeper to find a wide range of suppliers producing or bringing to market all manner of e-machines and related technologies, from innovative motor designs to e-transmissions to ultra-fast switching devices. Advancements in batteries and charging infrastructure are essential to the success of automotive electrification, but development of e-machines and an industry to support global electric vehicle demand are garnering a fair share of attention from automakers and suppliers striving to meet the challenges of this new brand of transportation. As our Awards Intelligence Survey indicates, OEMs and suppliers are keenly aware of the need to improve the electrical components such as the rotor, stator, and electronic motor controls to produce the kinds of highly efficient motors necessary for the coming wave of EVs. They know that, in addition to batteries, investment that results in motor efficiency will translate directly into smaller batteries or more range or improved performance. In addition to R&D, investment in e-machine production also must ramp up significantly to meet the coming demand of an EV market expected to quintuple during this decade. Some 1,600 electric vehicle nameplates will enter the global market in the coming decade, including 500 in the US. And unlike internal combustion engine vehicles, EVs often are designed to incorporate more than one motor, whether to provide extra propulsion or all-wheel drive capability or both. When we estimate demand across various EV types, the number of motors averages 1.2 per vehicle. However, that estimate is likely conservative given factors such as higher market demand for all-wheel drive among EV buyers compared with purchasers of ICE vehicles. All of this translates into big business for companies positioned to supply e-machines or motor components to automakers seeking to expand their EV portfolios. As the EV market expands to more than 31 million vehicles by 2027, we estimate the global market for motors will grow to a $36 billion business by then, producing nearly 36 million motors. Automakers and suppliers are redefining their roles when it comes to propulsion system development, with suppliers often taking the lead due to their deeper knowledge of electrification. As electric vehicles proliferate, however, watch for OEMs to take an increasingly firmer hand as they scale up production and look for ways to differentiate their powertrains. Suppliers, at least for now, are leading the way in the development and production of e-machines, so we focused our report on researching and evaluating dozens of them, grading them based on product and market reach, relationships with automakers, and expertise in the field. So what's it all mean? As the automotive industry shifts to electric vehicles between now and 2050, R&D investment will transition to the improvement of e-machines as part of a larger effort to increase the efficiency of all types of EVs. The relationship between automakers and suppliers leans heavily to suppliers, at least for now, but look for OEMs to take an increasingly dominant role as the EV market matures and automakers seek more ownership of their e-propulsion systems. Thank you for tuning in to this edition of the Ward's Intelligence 6-Minute Webinar. To make sure you don't miss future episodes and other summer festival of automotive content, follow the link listed on this slide and in the description below.